This instruction is on the modulus of elasticity experiment. The modulus of elasticity is the slope of the linear region of a stress-strain curve. That means that we need a way to get the amount of stress and a corresponding amount of strain on in increments on the material that we're testing. The material we're going to test is the aluminum of an aluminum beam, and the way we're going to get the strain is by a strain gauge mounted on the beam, and that will read the strain directly. It actually reads it in microstrain, times 10 to the minus 6 inches per inch. So that will read the strain directly. Now we need to get the amount of stress in that same element, the amount of stress at that location on the beam. And the beam is in bending, so the way we're going to do that is incrementally put the loads to create a bending stress at that location, and we can calculate that amount of stress by the amount of moment and the section modulus. The amount of moment will be the force on the beam, at the end of the beam, the amount of force here, times the lever arm, which is the distance from the application of the force to the center of the strain gauge. And the section modulus is a function of the beam dimensions. Now, this equipment that you're using is called a strain indicator. It will read in microstrain, and it's very simple to use. It's already been wired up to read that strain gauge, and you simply hit run. You set the balance to 0. It's very sensitive, so you're going to have to be very patient to move out of the vicinity of the gauge, because it picks up your body movement, and balance it, and then incrementally load, and in increments and then decrements, the amount of incremental load to cause the stress, and read the stress and the strain. So, read the force, the load, and the strain. So what you'll end up with is a list of the loads and the strains, and in your spreadsheet I would put them in one big column, because you're going to need to find the slope of all of the data points, so I would put them in one big column. And then you're going to need to calculate additional columns in order to get the stress and the you need the strain, by the way, in inches per inch, not in microstrain. So that'll have to be converted. Be very careful with that. It needs to be in inches per inch, not in microstrain. So that's what you'll need in the spreadsheet. The plot that you'll use, what you need to do is make 2 series in the Excel spreadsheet. You need a different series for the ascending and the descending, so that you can see if there's hysteresis as you take the loads back off. Most of this data shows essentially no hysteresis. So you'll notice that's what your plot needs to look like, and then you need to change the titles so that it represents the X and Y axis with their units.